So here we're going to look at the mineral sets that you'll be using in class, and it looks like this, and it's got minerals in some number. That just helps me identify what set groups are working with. But what we're going to look at here are different minerals, and they're found and located directly inside the cover. It'll tell you the mineral that we're looking at itself, right? So there's 30 samples in here. So this is our mineral sample set. And then another ancillary or extra handout that we have here are just the minerals and their elements that represent them, that make them up, that compose them, if you will. So you'll need to familiarize yourself with this handout here. And there's even another handout, but we're not quite ready for this. This is what group the mineral is found in. It's either a silicate or a non-silicate, and these are the primary silicate groups. So there's a couple different handouts that you'll need down the road. We don't need them right now. But for now, I do want to make sure we have a chance to get exposed to these minerals. I think that these minerals will help us learn the material by having these interactions where I can actually talk you through using these minerals. I think we can cover a lot more ground than just learning them in class. So I'm going to just make some real general observations here. I hope you have a chance to see that some of these look really metallic, right? This one here, this is galena. This is, it's a very metallic, very much a metallic-y sheen to it, right? It's got this metallic luster. So that's going to be a term that we'll be using here. Here I've got this is a pyrite. This is actually chalcopyrite. It's kind of like a goldish. And here's actual pyrite. So this is fool's gold here. Fool's gold is iron pyrite. It's just that. It makes people think that they found gold when really they're just fools. And we've got other materials that aren't metallic at all. Here's a halite. This is table salt, right? You can look at this and you can see it's got perfect 90-degree angles, right? So if I put my fingers together, I see that it bonds at a perfect 90-degree angle here. So I could be like, oh, well, that's a very distinctive feature here. That 90-degree angles tells me something about this particular mineral itself. So all of these minerals that are within this set here have unique features. And I can even show you, here's Illinois State mineral. It's a very, very cool mineral. It's fluorite, and this kind of has a unique shape to it. It's just a unique characteristic just to this mineral. So each mineral is going to have its own characteristic that kind of makes it identifiable. These are very sheety. This is a biotite mica. More often than not, micas are very easy to spot because of their, let's just say their sheetiness. Very, very cool sheetiness. So we're going to be learning minerals. We're going to be taking a look at the different types of minerals that make up our worlds. And in doing so, we're going to actually have a chance to learn the chemistry as to how and why they bond together. More importantly, we can start talking about some of the tests that we're going to be running on the minerals themselves. Because when you pick up a sample, there's a couple different tests that I think you're going to want to begin to learn how to go about doing. So let's say a couple of the easiest ones are to look at the luster. So let's say I pick up this sample here, and you don't know what this sample is off the top of your head, but if you can see that it's got a metallic luster, just by me identifying that metallic luster, it already begins to categorize what this mineral sample is. So it's a starting point. So I'm going to have you take notes here. Luster is a very good starting point for identifying a mineral. So this would be a metallic luster. So it can have all kinds of different lusters. Lusters some examples that you'll be needing to know is it glassy? Is it a term called vitreous? Vitreous or glassy, they kind of mean the same thing. Right, this one here's kind of got a glassiness to it. Does it have a dull or earthy luster? This sample here has a dull or earthy luster to it. We can talk about a pearly luster, and actually the sample that I'm holding right now has a lot more of a pearly luster than others, but I don't know if you could make this sample out with the lens that's showing here. Or does it have like a silky or a greasy luster, as if it was coated in oil? And you'll find that talc here, it says a very greasy luster. It's like touching a 16-year-old boy's forehead. It's kind of nasty film to it, so no offense. Secondly, we can take a look at color. And color's not really a primary, but it is a go-to. You can use it, but I would say don't solely base that mineral name when we start identifying what the mineral is. Don't solely base it on the color. The color it's a starting point, but it's generally not the only diagnostic property. It's simply a tool. It's one of many different diagnostic properties to help identify the mineral. Next one I can do is streak, and I'm going to start off with a real simple one. You'll find that we have these porcelain plates. These are literally porcelain plates, and if I'm picking up a light mineral, I'm going to test to see what its streak is. I think it's important for you to test it. And if you see that I just rub this streak here, streak is simply this mineral in powdered form. I can also rub my finger on here just to confirm that it's a white or light powder. So the streak is important. It's simply the mineral in its powdered form. Then another test we can look at is, well, what is the crystal shape, or what is the habit? What is the pattern that goes with this? So here I'll just pull out a mineral here that's got a definitive shape to it. And this one here happens to be calcite. It's the base mineral for limestone. And this one here has what's called a rhombohedral shape. If you can see, let me shine it from above. It's like it's like it was 90 degrees, that somebody just went poof, and they moved it out from under. So it's not actually, it's not at 90 degree angles at all. It's actually been tilted ever so slightly. And we'll add those numbers to this as we go. And last but not least, we can use hardness. And hardness is an important one. Hardness just tells me, well, when I use Mohs hardness scale, and it's on page 37 in your textbook. I actually just ironically happen to have my textbook out and open to this page, just looking at it. Mohs hardness scale, it's a relative hardness, and we're going to have different samples that we'll be able to test. So your fingernail is roughly a 2.5 in the hardness world. Copper penny is 3.5. A wire nail, 4.5, a glass or knife blade is about 5.5, and a streak plate's about 6.5. So that means if and when we rub an object on another object, the softer object is then powdered. So if I can scratch it with my fingernail, it's safe to say that the mineral is softer than a 2.5. So I'm going to go back to my kaolinite, this very soft mineral, and I can scratch this with my fingernail, and you will see it's softer than my fingernail. Right, my fingernail was undamaged. So I know that this mineral is softer than a 2.5. But for this sample here, calcite, I can't scratch it without damaging my fingernail. So I know it's harder than my fingernail itself. However, I can bust out a copper penny. So it's probably going to be loud. Okay. So I got my copper penny. I'm going to go ahead and try to scratch it. I got to look very carefully. Bingo. No scratch. No scratch. That means the penny is harder than the calcite. So if I look at Mohs hardness scale, it works out very nicely. Because calcite is on here. It is a reference mineral. Calcite is a hardness of 3, where my fingernail is 2.5. So calcite can scratch my fingernail, but can be scratched by a copper penny. So a copper penny is harder. So then calcite is what is in the powdered form when rubbed together. And you can do this and you'll have to do this. You'll have to learn this with all these different minerals. So as we move on, we've got these steel pieces too, these steel washers. These work out very nicely. They're galvanized steel. And we have these pieces of glass as well. So we're going to have multiple test samples. We're going to have, obviously, your fingernail. You're going to need to bring that one from home. We have a copper penny. We have, glass. We have steel. And we have porcelain. We have both light and dark. And the light and dark work out best to allow us to see the difference between light and dark minerals in their powdered form. So I don't know if you can see this here, but there's a piece of glass. So we'll be scratching and kind of finding hardness on that. And then last but not least, we're going to be looking at cleavage, essentially how a mineral breaks. And we call it if it breaks in very nice planes, we consider that or call that a cleavage plane. I'm just going to pull one out that's an obvious one. And this here happens to be galena. And galena has very nice 90 degree, much like that of halite or table salt. And this, if it were to break, it would break off in very nice, clean cleavage planes. We call these a crystal face here. And this would break whereas this mineral here would break into irregular or fragment. It would fragment itself. So when we talk about a cleavage plane, we have cleavage planes if they're nice surfaces. We would have a fracture if they fragment or break into irregular pieces. So if you look at this from all different angles, you would see that this one here would fracture. So there we have it. We've gone through the really basic tests that we're going to be doing with minerals. So we're going to be finding mystery minerals by knowing how to run the different tests. We can find luster, color, streak, crystal shape, hardness, and cleavage or fracture. And those are the primary tests that will help us learn and determine what the mystery minerals that we'll be working with are.